Good morning, all of you. Today we are back with the chemistry classes and we are going to learn about atoms and molecules. Ancient Indian and Greek philosophers have always wondered about the unknown and unseen form of matter. The idea of divisibility of matter was considered long back in India around 500 BC. An Indian philosopher, Maharishi Kannad, postulated that if we go on dividing matter, that is Padarth, we shall get smaller and smaller particles. Ultimately, a stage will come when shall come across the smallest particles beyond which further division would not be possible. And he named these particles as Parmanu. Another Indian philosopher, Pakura Katyama, elaborated this doctrine in a combined form and gave us various forms of matter. Around the same era, ancient Greek philosophers Democritus and Lysippus, they again suggested that if we go on dividing matter, a stage will come when particles obtained cannot be divided further. Democritus called these indivisible particles atoms. All this was based on philosophical considerations and not much experimental work to validate these ideas. But by the end of the 18th century, scientists recognized the difference between elements and compounds and naturally became interested in finding out how and why elements combine and what happens when they combine. Antoine Lavoisier laid the foundation of chemical sciences by establishing two important laws of chemical combination. So, we are going to see these laws of chemical combination. First law states that law of conservation of mass given by Lavoisier in 1774. According to this law, it states that during a chemical reaction, matter is neither created nor destroyed. That is, total mass of the product is equal to the total mass of the reactant. For example, you can see calcium carbonate. When it is heated, it gives out calcium oxide plus carbon dioxide. So if we take 100 gram of calcium carbonate and we heat it, we get calcium oxide, that is CaO, and carbon dioxide, that is CO2. So we get 56 gram of calcium oxide plus 44 gram of carbon dioxide, and if we add up these two, we get 100 grams. So we can see in this reaction, from the reaction, that when CaCO3 is heated, it gives calcium oxide plus carbon dioxide in the same proportion. So we see that the 100 gram of calcium carbonate was utilized during the reaction, and the mass of the product is also 100 gram. So by this we can see that the conservation, the mass of the reactant and the product is same. So the law of conservation of mass states that matter is neither created nor destroyed. That is, the mass of the product is equal to the mass of the reactant. Clear? Next we will see the second law of chemical combination, that is law of constant proportion.